Thank you, Monica, for inviting me to speak today. I want to start out my talk by just saying at the outset that I'm not a scientist, I'm not a researcher, nor an academic. My role is that of storyteller. So today I'd like to tell a few stories about sustainable design and how I think that particular interest intersects with technology. So the question is, I'm not seeing my slide. The question is, how do we build for a sustainable future? I want to address that by sharing 4 buildings that I've written about in the past year. While in general they represent some of today's best practices in sustainable technology rather than future technologies, I think at the same time they are models for how technology will continue to be used in the years ahead when addressing environmental concerns. I'll start with 3 buildings. All at a relatively small scale. First on my list is the Merchants Mill Pond Visitor Center by Frank Harmon. This modest structure recalls the memory of a historic mill that once occupied the site while incorporating a low-tech approach to sustainable design. The building, as you see, is not a copy of an old farm building, but it does evoke some of the same qualities. Here you see the deep overhangs, the generous use of clear-story windows, and a cistern that captures water off the roof. The exterior rain screen wall here is reclaimed cypress. The entrance is beneath a low roof into a lobby whose ceiling slopes up to frame a vista of tall trees. Flooring here is all recycled heart pine. Here's what that overlooks. It's a 760-acre mill pond and a swamp that's home to ball cypress and tupelo gum trees, primitive species of fish, and myriad turtles. When I spoke to Frank Harmon, he told me he envisioned the visitor center as a big, well-lighted tent with lots of flexibility. So this bright classroom space speaks directly to that. Outside of that room, a translucent awning reduces glare inside, but still allows daylight to pass through. This building was commissioned by the North Carolina Division of Parks and Recreation, and it includes a strong educational component promoting environmental awareness. The project is targeted for LEED Gold. This is the division's first LEED project, and I think it makes an important contribution because it demonstrates that even small buildings can have important environmental impact, both through the ways they conserve natural resources and through the lessons that they teach. The next project I want to show is by WRNS Studio. It's the Watsonville Water Resources Center, located in the Pajaro Valley near Monterey. This was voted a top 10 green building by the AIA Committee on the Environment, and the facility is a joint effort of several water conservation agencies to address the problem of saltwater intrusion into the local water supply. This is water that supports a $400 million farming economy, so it's precious. The building and the landscape weave a narrative about water use and conservation that raises public awareness. A breezeway at the entrance divides the building into 2 zones, which yields huge operational savings. On one end is a water quality laboratory. Its function demands the environmental stability and the safety provided by modern HVAC systems, which are big energy drains. The other wing is primarily office space with operable windows and vent stacks that make natural ventilation a reasonable option. There's also in-floor radiant heating and cooling. Both a large public conference room and an employee dining room are placed next to exterior patios, which are accessed by accordion-like glass walls. Here's one of those patios. Notice here how the wood screens are placed to block prevailing winds. The redwood siding here is another really great story. The city was about to clear several redwoods for fire protection and chop them up into mulch. The architect said, hey, we can mill those logs locally and use the wood in the building. During rainfalls, water runs off the shed-like roof, down rain chains, and into rock-lined swales. This building is slated for LEED Platinum. The third of the small projects I want to show is the Prescott Passive House by Studio 804. As many of you know, and your students are aware, this is a 5th-year architecture studio headed by Dan Rockhill at the University of Kansas. This low-income house is the studio's first attempt at passive construction with standards set by the Passive House Institute in Germany. The goal of 90% energy savings was pursued in two ways. Number one was heavy insulation, which blankets the entire house. There are 9 inches of foam beneath the basement floor slab, and then 16-inch thick walls and 22-inch thick roof that cut heat transfer through the building enclosure to almost nothing. The second key strategy was to make the building airtight. They did this by pressurizing the house with a blower door, which you see on the right, then walking through with a smoke machine to visualize where air leaked through the enclosure. This was a pretty clever diagnostic tool that allowed for repair of the leaky joints before the walls were ever finished out. Louvers over the south-facing windows control heat gain, and a rain screen made of charred Douglas fir provides a UV-absorbent black finish. The interior volume allows full penetration of daylight, even illuminating the bathrooms obscured behind translucent glass panels. It has triple-pane, double-insulated windows that are all important to the house's energy performance. This 1,700 square foot residence does include heating and cooling to keep the residents comfortable during Kansas' scorching summers and frigid winters. This consists of a single, very small, mini-split heat pump, just the type you'd find in the wall beneath a motel window. So before I move on to the next subject, let's consider, what do these projects all have in common? Well, they're publicly funded projects that are all intended to demonstrate sustainable values to their communities. They're on rural sites or open sites, and their low budgets tend to drive the designers toward reliance on passive systems. My contention here is that until homeowners and small businesses create greater demand for sustainable design, it will continue to be public agencies and institutions that set the example. In a way, I was reminded of what Bruce Shirley said this morning, that new technology is old technology. These use a lot of old technologies. Anyway, small-scale buildings on rural sites are not the direction our world is headed. So, where are we going? Well, by 2030, 60% of the world's population will live in urban areas. So how do we design for sustainability at that scale? The bigger task of saving our environment is how we build in large population centers, particularly in rapidly developing countries like India and China. In my editorial role at Gensler, I've been writing a lot lately on a large-scale project that is just coming out of the ground. It makes a really good counterpoint to these first 3 buildings. Rather than housing 3 or 10 or 30 people, this building is designed for a community of thousands, set in the heart of Shanghai. This project, designed by Gensler with the participation of many of our offices around the globe, is the Shanghai Tower. For anyone who's not familiar with the project, let me give you just a little bit of background. The commission was won in an international competition and is being constructed in the city's Pudong district, which is Shanghai's new commercial center. Groundbreaking for the project was in November of 2008. Completion is set for 2014. Shanghai Tower will anchor the city's financial center, which in the coming generation will become the gateway into the world's largest economy. It will complete a collection of super tall skyscrapers that also include the Jinmao Tower by SOM and the Shanghai World Financial Center by Kohn Pedersen Fox. Shanghai Tower will rise to 632 meters high with 121 occupied floors. The building is conceived as a series of 7 stacked zones. What you can also start to see in the slide if you look closely is that the core of the building is made of cylinders stacked on top of one another like a tall, although an extraordinarily tall, wedding cake. The sculptural glass form is actually a second skin. The initial form of the building, a curved triangle or a cam shape and plan, was refined through lots of testing. The rounded shape, the 120-degree twist of the building, and the asymmetrical form significantly reduces wind loads, which has a direct effect on the amount of structural material needed to support the tower. Working with us on structural design is the engineering firm Thornton Tomasenti. These studies also examine the rate at which the building is scaled, or how it gradually narrows from the base to the top. In the center, that's the final choice. A scale model was created to study the form in a wind tunnel. Other models were subjected to shake table tests to predict its performance in a seismic event. The building meets the ground with a 6-level retail podium that is programmed as a magnet for urban activity. Most people will enter from a transit stop beneath the building and emerge into a large atrium space with giant windows facing the city. At the base of each zone is a sky lobby with amenities like shops and restaurants that support the building's population. Here in the plan, you can see the impact of a building with two skins. There's open space between the triangular glass outer wall and the circular inner wall. These conceptual renderings begin to suggest the unique experience those spaces will deliver to occupants of the building. Moving up in the building, here's a typical office floor plate. Closer to the top, here's how we envision the configuration for hotel rooms, and at the very top, an observation level. All that is background for discussing the topic at hand, and I have to say, sustainability is an issue we take very seriously at Gensler. For such a large building, the targets are ambitious: LEED Gold certification, and for recognition in the local market, the China Green Building 3-star rating. Energy efficiency is a starting point, with major energy savings coming from the configuration of the mechanical systems, thanks to MEP engineers Cosentini Associates, and via lighting controls. Predicted annual savings to the client equal about $2.3 million. The building's double wall system is used to great advantage as a thermal buffer. In addition, China's building codes are sensitive to the impact of sunlight reflecting off buildings. This had a big impact on the outer curtain wall's design. 2 schemes, one staggered and one smooth, were studied, and those studies revealed that a smooth skin of angled glass was actually less desirable than a staggered skin made of glass panels set vertically. So staggered wins. The design and construction of this facade is another story of technological innovation in itself, but we don't have time for that one today. In addition, electricity demand is reduced by using a gas-fired cogeneration system and on-site ice making. Then, to demonstrate the effectiveness of wind power, the crown of the tower is being equipped with wind turbines. And heating for the building will be augmented by geothermal heat pumps. The tower also incorporates intelligent building controls that lower energy costs by monitoring and adjusting systems such as lighting, heating, cooling, ventilation, and self-generated power. Lighting controls alone will save more than $556,000 each year in energy costs. Materials for the building will be sourced when possible from vendors and manufacturers within a 500-mile radius of the city. In addition, 1/3 of the site will be dedicated green space. The efficient irrigation systems combined with plant materials that require low watering all will reduce overall water consumption. And there'll be a building-wide recycling program to divert glass, plastics, metal, paper, and cardboard from landfills. Shanghai Tower is designed to be the most water-efficient high-rise in the world, using rainwater harvesting from the roof, recycling, and low-flow fixtures to decrease water consumption by 40%. That computes to 675 million liters of water per year, or enough to fill the lake in Pudong Century Park 5 times over. All told, these sustainable measures are calculated to lower the building's carbon footprint by 45 million kilograms per year, the equivalent of 99 million pounds. Again, that's equal to the positive environmental benefit of 5 forests the size of Pudong Century Park. So this is just one story. It's one firm's effort to raise the bar for high-performance, super tall buildings. It's the kind that will continue to be built in the coming decades as developing economies eclipse our own. At the same time, it's a story of optimism, an assertion that urban density need not occur without regard for environmental and social consequences. But unlike the small projects I showed at the start, buildings in this category rely almost entirely on technology, and in this case, more sophisticated technology spanning a range of disciplines, as a means to that end. Thank you very much.